Hello and welcome to Mukul Sharma Data Science. Today we are going to talk about types of data. When we are working with data in data analytics, when we are analyzing data, we come across all kinds of data, all types of data. And to proper analyze data, to properly work with data, to get the best results out of the data that we have, we need to know the type of data it is. Because one data set can have various types of data. And to work best with that kind of data, firstly, it's important to know what you're dealing with, what exactly you're dealing with. So, what kind of data you're dealing with. And today we're going to talk about two categories of data, two differentiations of data, which is quantitative versus qualitative data and discrete versus continuous. So, let's begin. So, as far as qualitative data is concerned, that is simply a data that you can describe. Yeah. So, it describes qualities or categories, but it does not talk about numbers. It does not have quantities in it. For example, the data might have a gender, whether a person is a male, female, or other. It might be talking about colors, red, blue, green. If it's about car, type of car, SUV, sedan, hatchback, or a country, India, Japan, Brazil, or a name. Yeah. So any qualitative data which has nothing to do with numbers, it might describe any quality, any category. It might be, ordered data. For example, it might be hierarchy in a particular office. Yeah, manager, senior manager, and so on. That can be a qualitative data. So the key is, what does it answer? It answers the question what kind or which category. Yeah, which category it does it belong to, or what kind of data it is. So you cannot find an average color or average gender. So let us say that in a qualitative data, you cannot apply any numerical methods to it. You cannot apply any statistical method to it. Yeah, you can not find any mean or a median or a mode or a standard deviation. We'll talk all about this in our upcoming videos, but you cannot apply any statistical method to any qualitative data, and that's the catch. Now let's talk about quantitative data, data that you can actually measure. Now, quantitative data, as the name suggests, is numerical in nature, something that you can count or measure. Yeah, like an age of a person, like an income 50,000 rupees or dollars, height 170 centimeter, number of students in a class. So let's say number of goals scored by a football player, the temperature in a day, yeah, the high temperature, maximum temperature or minimum temperature, the speed of the car, anything that you can measure, yeah, anything that has a value, that is a quantitative data. So the question that it answers is how much or how many, and as compared to qualitative data that we just discussed, which cannot be, on which mathematical operations, statistical operations cannot be applied. Here in quantitative data, you can actually apply mathematical operations like mean, median, correlation, regression. And why do you do it? Because you want to make sense of that data. Yeah, pure numbers would not tell you everything about the data. So you need to make certain conclusions about that data. That is what data analytics is all about. What do you make of any data that you have? And in quantitative data, we work on such data and we arrive at such conclusions, and then we correlate it with the qualitative data. Yeah, all of this we will learn in the subsequent videos. So to summarize, quantitative data, the nature is that it is the data of numbers. Examples, as I told you, can be age, income, height, score, temperature, or anything like that. Question that it answers is how much or how many. Whereas qualitative data, the nature is categories. Examples can be gender, name, color, brand, or anything. Question that it answers is what kind or which one. Now let's come to discrete data. Now discrete data, so within the quantitative data, there are two kinds of data. One is a discrete data and another is continuous data. Now what is the difference? Now discrete data is countable numbers. So it is data that you can count. What do you mean by it can count? So how do you count? You say 1, 2, 3, 4, 5, 6. You don't say 1.3, 1.4, 2.5. That is not counting. That is not how you count things. Yeah, counting is usually in specific units. So it takes specific values. Usually they are whole numbers. You cannot have half a student or 2.7 cars. Yeah, so for example, a football player cannot score 3.5 goals. He can either score 3 goals, 4 goals, 1 goal or 2 goals. Yeah, so the discrete data, the catch is that it takes specific values. Yeah, so for example, number of students in a class, number of goals scored, as I told you, number of bedrooms in a house. So these are finite countable values. There are no decimals or fractions, and they're often represented by bar charts. What are bar charts? We will discuss in subsequent videos. But bar charts again have the bars contain specific values. Yeah, that's how you show in a visual way. So discrete data has specific values. It does not have values in between. Whereas continuous data is a data that you can measure. Yeah, so there's a difference. Discrete is something that you can count. Continuous is the data that you can measure. So it can take absolutely any value within a range. For example, a person's height can be 170.2 centimeter, 170.25 centimeter, and theoretically it's an infinite precision. Yeah. So similarly, temperature you can have 40.3 degrees Celsius, 39.78 degrees Celsius. It is not necessary. It will only be 38, 39, 40, and so on. So examples are height, weight, time, distance, temperature, price. Even something like a GDP or an inflation rate is continuous. Yeah, something like, let's say GDP is 7.8% year-on-year growth. Inflation rate is 4% year-on-year growth. So it is continuous. So key points are infinite possible values there are in a range. It can include decimal or fractions, and they are often represented by histograms or line graphs because there are no breaks in between. So line graphs are absolutely perfect for continuous data. So in a summary, a discrete data, it is countable. It does not have any decimals. Example, students, cars, goals. You cannot have a 2.5 car. A student cannot be 4.5 students in a class. And the chart is usually a bar chart. Continuous, measurable. They can have decimals, height, weight, time, and the ideal chart is a histogram. So let us see. So let us see an example data. And in this data set, I have included all kinds of data that we just spoke about. So in the first column, you have student ID 1, 2, 3, 4, 5. Then you have gender. Then you have course, hours studied, assignments completed, height, satisfaction level. So what do you think? Which variable is what kind of data? So let us see. Now student ID. Yeah, for example, 1, 2, 3. It's a quantitative data and it's a discrete data. It's quantitative because it has certain value. It is discrete because it can only take certain values. So countable unique numbers, identifiers, though often treated as categorical for analysis. Usually student ID, customer ID are usually taken as categorical data. Yeah, so usually they're not in a very strict sense quantitative, but they are discrete quantitative. The mathematical applications are usually not performed on such data, but it's a quantitative data. Gender, male or female. Yeah, so clearly a qualitative data. It's categorical. It describes the quality. It does not describe any quantity. A course similarly is a qualitative data. Whether a student is studying economics, data science, statistics, again it's a categorical data which tells which kind of course it is. Then number of hours studied is a quantitative data, because you are actually counting the how many number of hours did a student study this particular subject. So it's a measurable, but it is continuous. Yeah, because you cannot just study 2 hours or 3 hours or 4 hours. You can study 2.5 hours also. So it's a continuous data within a quantitative data. So it is measurable and can take decimal values. Then assignments completed. This is a quantitative data, but it is a discrete data. You cannot have 3.5 assignments completed. Yeah, you can have only certain specific values of assignments which are completed. So it is countable and whole numbers, and there are no fractions possible. Height is a quantitative but a continuous variable, because it's measurable with an infinite precision. You can so there are not specific values of height. You can have decimal values also. Satisfaction level is a qualitative data, high, medium, low, but it's a ordered qualitative data, because there is a hierarchy of this particular categories that are there. So this is, in summary, you have either a quantitative or a qualitative. First you see whether your data is a quantitative data or a qualitative data. And if it is a quantitative data, whether it's a discrete or a continuous data. Now, why is it important? Now, knowing your data type is the foundation of data analysis. As I told you, first you need to see what kind of data you're dealing with. Then on the basis of that, you will firstly decide what kind of chart you will use, because as I told you, because different chart types are applicable for different types of data. Then you will see what kind of statistical test you will apply if it's a quantitative data. Then how your machine learning model interprets features. We'll come to the machine learning models later. But before you're running fancy algorithms, you have to make sure your data type. And that's how the real data scientists think. So I hope in this video, all your doubts of discrete data, continuous data, which can be a very confusing topic for any beginner in data science, is absolutely clear. If you have any questions, you can put them in the comments. Thank you.